Start, sir.
Okay. Good morning, everyone. So if you have any question, any query, then please tell us. Already we have completed almost the linear programming problem, including the dual simplex method and others. What I am finding, there is only one question till now in the Google Drive, that is, I think Ghazal has given a query that is regarding exam registration. What I could understand that he is having on 20th December 3 exams simultaneously. So there is a class. I think if you write down a mail to NPTEL, they will try to take care, I feel so. So Ghazal, you please write down an email to NPTEL office, Madras, so that they will try to find out any solution is there or not, or they will try to do something so that you can give exam for all three. I can understand that your NPTEL exams are mandatory. So please contact them. Beside this, any other question? Professor Chakraborty, you want to say something?
No, just I want to say that I have taken the portion of nonlinear programming. Hopefully it has not yet been started.
No.
That's why they must be having query from linear programming only. Let us wait for them, whatever they want to know. We are here to listen to them and give our input.
Sure. If in the channel any question is coming, please inform us, because otherwise, if they do not have any question, then it is difficult to discuss, I think. Because most probably, as Joshua told, they are going through the sensitivity analysis now of LP.
Yeah.
So after this, that nonlinear part will come.
Yeah.
But how we will get any question is coming or not?
Even I'm not finding how many are there in the channel at this moment.
No, channel. Have they given channel? YouTube link is given.
Sir, this video is broadcasting on YouTube, and the student can post their query on YouTube only. From there, we will redirect you their queries. Then we can discuss, and that will be broadcasted again.
And, okay, given channel YouTube link.
Sir, this video is broadcasting on YouTube, and the student can post their query on YouTube only. From there, we will redirect you their queries. Then we can discuss, and that will be broadcast.
That's fine.
Oh, there is a query. Query has come from Shorav Jadhav. Can you suggest some resources to study programming for the optimization?
That this video is broadcasting on YouTube, and the student can post their query on YouTube only. From there, we will redirect you their query.
Sir, please mute the YouTube audio.
That's fine.
Oh, there is a query. Query has come from Shorav Jadhav. Can you suggest some resources to study programming for the optimization? Professor Goswami, want to say something?
What was the query?
From there, you will redirect you.
I think some disturbance is coming.
The YouTube audio.
That's fine.
Oh, there is a query. Query has come from Shorav Jadhav. Can you suggest some resources to study programming for the optimization? Professor Goswami, want to say something?
What was the query?
Query is suggest some resources to study programming.
Programming means
I think programming means what? Oh, there is a query. Query has come from Integer Lpp. Can you suggest some
Caller, please mute the YouTube audio.
I think someone yeah.
query is
Okay, Pasha Chakraborty, you can also tell. So just give some name. Programming means I think some book name or like that. It is already there also.
yeah. Can I say something?
Sure, sure.
Yeah, the first question is regarding the programming for optimization. I do not know exactly which kind of high-level language programming you are talking about. And now, if it is C, then I can say that there are the programming are available, but you can use the MATLAB also. MATLAB, some toolbox is there for optimization that you can use it. Otherwise, there are other softwares which are freely available. Those are Lindo, Lindo, that you can download. But if you do not purchase that one, then there will be a limited number of variable and the constraint
Constraints.
restrictions that you can use. Otherwise, you can use QSB, quantitative solution for business or so. The name is that WinQSB. That also you can download and you can get answer there. You can get the answer from those software as well. But if you want to write program for that, then programs are available that you can just customize on your own way and you can do the work. This is the first answer of the question. The second question is that it has been said whether we will cover the Cplex optimization studio or not. Not really, because our course is mainly we are concentrating on the theoretical study of the linear and nonlinear programming. We haven't covered any software or programming part in it. Cplex is a very systematic software. If you want to learn it, that is separate issue, but it will not be covered yet. There is no scope actually from our side. Now another question came that Ritesh Jaiswal, he has written that ma'am elaborate few examples of unconstrained problems. First of all, the unconstrained problem has not yet been covered in your class. But if you have a still query, then we will contact you through our forum. Hopefully, through forum, our TAs can help you in getting a few problems on unconstraints. And you need not to worry even, because whenever we will cover unconstrained optimization problem, we will provide you sufficient number of assignments to do, and we will give you the feedback along with the solutions. That is a part, but if you want any extra questions rather the examples, that time when it will be covered, our forum will help you. Please put your query again when unconstant will be covered.
Yes, it has not been covered till now.
No.
It will start after maybe 1 week or something like that.
Yeah, there is another query from Ritesh Jaiswal that on the mixed integer programming, that now I request Professor Goswami, you have covered integer programming. Now the mixed integer programming, you want to say something about it?
About I think mixed integer programming was not covered, right? We have done only the integer programming, but if they are interested, then if you specifically write to the forum, I will request our TS so that they will give some theoretical aspect as well as few examples they will give you. I think that would be better.
That is fine. That is fine.
Because they will just give you the theoretical concept, how we are solving the problem and few examples and few assignments so that you
In
can
this,
learn it of your own.
sir, in this course also in the next week, the integer
Yeah.
programming and mixed integer programming problem will be covered in the
Oh, actually,
next
it is
week
there.
itself. Yeah, yes, sir.
Oh,
On
then
the week 6.
assignments are also there.
Yes, yes, sir, yes, sir. On the
Oh,
week 6.
okay, okay. So then there is no problem as such. We can always use that thing. Effectively, I think after sensitivity and duality, uh, we will discuss that part, mixed integer and integer programming part. And after that, unconstrained optimization will start.
Yeah, yeah. Now, there is no other query till now. Let us wait for their doubts.
Yeah. Professor Chakraborty, any other question is there or no?
No. There is no other question. That's why I'm just waiting. Let them. Now, Ritesh has written another query that is another. He has written another one is optimality criteria. What does it mean, Ritesh? If you please explain further, it would be nice. What kind of doubt you have on the optimality criteria? Is it for linear programming you are talking about? Yeah, graphical solution of LPP. Sir, please discuss graphical solution of LPP.
What they are asking?
Sir, please discuss graphical solution of LPP, linear programming problem. How to explain? Because this has already been covered in your class. And
Yes.
hopefully they will get the repeat videos. That's why discussing in this forum would be little difficult in that way. What do you feel, Professor Goswami?
Just I'm giving one, I'm sharing this. Effectively, what will happen, there will be some constraints of the form ax less than equals b or something like that. So for each of them, someone has to draw the equation something like this way or whatever it may be. Whatever constraints are there, whether it is less than equals from here, you have to find out the feasible region. On the feasible region, your solution can be at the endpoints only, one of these endpoints. So from here, you have to find out at one point you are obtaining the solution. Usually we use the graphical method whenever number of constraints are less and we can draw the graph very easily. And of course, if you have the two-dimensional, that is two variables, because if you have more number of variables, it is difficult to explain through graphical method. So at first what we do, we draw the equations like this way. So this is constraint I can write down this is constraint 1, this is constraint 2, like that way. And from there, you find out the feasible region. So on this shaded region, your solution will lie. And the solution will lie on one of the endpoints only. So out of these, say, 4 endpoints are there, at what point you are getting the optimum value, that is minimum or maximum, that you have to find out. I think already we have done it, but in nutshell, we can tell like this. Professor Chakraborty, is it okay?
It's fine. I feel it is understandable very well. Now, about this is over to students. If they have further query, they can ask us.
They can ask and we can
We can clarify
yes.
further.
Sir, there is another question. Please discuss integer LPP.
I think integer LPP we have not covered, right? Suman?
Sir, in week 5, there is IP and MIP problems, but week 5 is already covered.
Week 5 is?
But week 5 is complete. It's on the online. Week 5 videos are online.
So already we have done. This has been covered, integer programming? Or not?
Integer programming is covered.
So what is the question?
Question is, please discuss integer LPP.
You have any slides, Joshua?
Slides? No, I don't have any slides.
Joinika, can you provide something?
Ma'am, I'm searching in my laptop. If I get something, I'll definitely provide you.
Just try to find out at least one problem or that video if you have, then it will be easier for us to explain.
Now there is another question from Kalpesh that please elaborate continuous or probabilistic variable with practical examples. I think this is beyond our scope of our course because we are not discussing really probability theory in our syllabus.
Just in short, you can tell just for just 2-3 minutes maybe.
Are you talking about the continuous variable with practical example? In that case, I can say
Yes.
that if we consider the time between the morning 10 a.m. to night 10 p.m., if that could be a variable, decision variable in a linear programming problem somewhere where the problem is very much dependent on time, then in that case we can say that the variable is continuous variable. But in other words, if we say that number of tables, number of chairs, that cannot be continuous because always that must be integer. These are all discrete. Now if we say that something like a number of amount of some raw material, that is continuous variable because the variable can take any value which is decimal even other than integer. That's why this will just move in the real line in a continuous line. That way we can define. Now regarding the probabilistic variable always this is related to the chance factor. Now we consider the chance factors in the linear programming, but really it has not been covered in this course. But we say this way: if some constraint is happening within certain probability, that means there is a chance to happen this constraint, that is chance is 0.5. That means in 50% of time we are expecting that the constraint will happen. If the chance factor is not associated, then that must be considered as a probability value as 1. That means the constraint is there, definitely there. That's why probability theory can be associated with the linear programming in that way. But if you are interested, you can read on the chance constraint programming problem or two-stage programming problem. Now, that is the thing I can just say to motivate you to read more about this chance constant programming. Otherwise, we generally do not use the probabilistic variable in optimization problem. Any other query, Kalpesh? Oh, there is another question from Dipayan Dash, basic philosophy for solving nonlinear programming problem. Now, basic, this is the, we have said something in the introductory portion of the nonlinear programming problem. The basic philosophy is that though we are considering in our theory that the function like the profit function, the resource constraints, we are considering in linear fashion, but generally in reality it is not happening in that way, because everything is non-linear. Whatever linearity we are assuming, most of the cases these are the approximation of the real fact. That's why basic philosophy, if you ask me, I would say if you just work in the real environment, you will see in most of the cases, you will see the nonlinear programming is most applicable than the linear programming. But we learn linear programming because unless we understand how the linear programming problems are being handled, if we do not understand how the optimality is being reached for the linear programming problem, if we cannot visualize how the optimal point is associated at the edge of the feasible space, then we cannot really, we are able to, we are not able to visualize for the nonlinear programming problem. Now, if you are really interested for the philosophical idea, I would say try to visualize the optimization problem in a geometrical plane always. If it is even a bigger problem with more than 2 variables, try to scale down it and try by considering few decision variables at in a constant way, constant level, but try to visualize the feasible space. Need not to draw all the time. Now, that is a good practice to learn optimization. Now, if the plan is not satisfied, you can ask many more questions after this. Sir, you want to add anything, Professor Goswami?
No, I will not add on this. Actually, Professor Chakraborty, yours is mute or no?
Oh, acha. No, unmuted.
Okay. So can I talk little bit on integer programming? Just I
That's
think
fine. That's fine.
that would be better, I think.
Yeah.
So effectively, you see, whenever we are writing, say, maximize or minimizing a problem like this, summation j equals 1 to n cj xj, subject to say summation j equals 1 to n aij xj. This is equals bi, and xj greater than equals 0. Here your I, of course, varying say 1 to m, and j varies from 1 to n. And one more condition is imposed, that is xj's are integers. So this type of problems, we call it as integer programming problems, where the variable xj can take the integer value only. It is not necessary that it will take any kind of value, whatever you have seen. Especially, I will give 1-2 examples. Say one is capital budgeting problem. Whenever you are talking about the capital budgeting problem, in typical capital budgeting problem, decision basically involves the selection of a number of potential investment. And the investment decision may be to choose among possible plant location or to select a configuration of capital equipment, or it may be to settle upon a set of research and development projects, something like this. So in these cases, often in these cases, your decision will be either you will go for it or you will not go for it. That is, your xj will be either 0 or it will be say 1. I'm talking about the capital budgeting problem. So in this case, your variable is taking some integer value only, so that you can write down your problem as, say, maximize summation j equals 1 to n cj xj subject to the constraint summation j equals 1 to n aij xj less than equals bi, your xj will be either 0 or 1. The objective is to basically maximize the contribution from all investments without exceeding the limited availability. Your limited availability is this part, this bi part. And your decision variable, that is the reason summation j equals 1 to n aij xj, we are making it as less than equals bi. And in this case, it can take the value xj will take the value either 0 or it can take the value as 1. So this is one type of example where we use this integer programming problem. So effectively, in the integer programming problem, your decision variable can take the value integer values only. Or if you see this warehouse location problem, in the warehouse location problem, what happens? In modeling the distribution systems, the decision must be about the decision must be about the trade-off between the transportation cost and the cost for operating the distribution centers. So please note this, that the decision we have to take, which will be a trade-off between the transportation cost and the cost for operating the distributor centers. As if you take any example, suppose that a manager must decide which of n warehouses to use for meeting the demand of m customers. I have m customers, I have some n warehouses. So to meet the demand of the customers, which warehouses I will use for a particular commodity or good. So decision to be made are which warehouses to be operated and how much to ship from any warehouse to any customer. So we assume something like this. Suppose yi equals 1 if warehouse I is open, or it is 0 if warehouse I is not open. You can write down something like this. And of course, xij is the amount to be sent from. Please note this, sent from warehouse I to customer j. whereas I to customer J. So there will be some relevant cost, like I can say FI, this is the fixed operating cost for the warehouse I, and CIJ, I can assume that per unit operating cost at warehouse I, plus the transportation cost for shipping from warehouse I to warehouse J. And there will be two type of constraints basically in this warehouse location problem. One is the demand DJ of each customer must be fulfilled from the warehouse, and goods or materials can be shipped from a warehouse only if the warehouse is open. So mathematically, if I have to write down the warehouse problem, I can write down minimize summation I equals 1 to m, summation j equals 1 to n, Cij xij, this is one part, this is Cij xij, this is related to the warehouse, plus there will be another cost will be added, summation I equals 1 to m fi into yi, this is related to demand. Subject to what will happen, the total fulfillment of demand, that is summation I equals 1 to m xij, this should be equals to dj, the entire demand it should satisfy, and obviously summation j equals 1 to n xij minus yj into summation j equals 1 to n dj, this should be less than equals 0, your xij should be greater than equals 1, and your yi, that is location, will be 0 or 1. So here if you see, this is actually is becoming mixed integer programming problem, where some variables are taking only the integer values, whereas some variable will be taking the integer or the real values. So like this way, there are various problems arises where sometimes it takes only the integer values and we call it as integer programming, or sometimes we use the sometimes we use the mix, that is variable, maybe integer, maybe any real number. So that we decide as the uh, mixed integer programming problem, and the solution procedure has also been discussed over here. Professor Chakraborty, is it okay?
It is fine. It is very much useful for the students, I feel. Now, but there is another query from LPP. Shall I move, or you want to or you want to elaborate the integer programming further?
No, that's okay. You just
Okay.
do it.
Okay, the next question is, I want to apply linear programming problem for reservoir operation. Now, demand inflow variables are continuous. Now, the question is it correct to say that we go for heuristic approach only if we cannot, this is a separate query. Now, the first query is I want to apply LPP for the reservoir operation where demand and inflow are continuous. Now, what is the query? I could not understand, but he said that he wants to apply. That's fine. Now, if you want to add anything, Professor Goswami?
No, you can tell it. Just let me see.
Yeah, the next question is it correct to say that we go for heuristic approach only if we cannot formulate our objective function and constraints as a linear problem? Actually, with the even for the this is the answer to Kalpesh and the next person as well, who is asking about the heuristic approach. Now, heuristic approach is something which is the last resort in any optimization problem, because if you cannot formulate in a closed form, rather in a very explanatory way, the objective function and the constraint set, certainly we are using the heuristic approach, but you will see all the time heuristic approach is not able, we are not able to apply even, because for heuristic approach certain other kind of information is very much necessary. That's why I would say there are certain other methods are also available whenever we are not able to formulate. The one of that is that we can apply the rule base. Rule base is nothing but the previous happening. If we can formulate in as a rule, that we can embed in an optimization problem. This is one of the ways generally we do when we are not able to form objective function or constraint as a linear or nonlinear function at all. But certainly heuristic is another approach. But for heuristic method, we need certain information to define the feasibility of a solution. That is very much necessary. I hope it is clear. Otherwise, you may ask further question on it. Professor Goswami, you want to add anything about it?
No, heuristic approach we use whenever we are not getting the solution in the closed form. We try to avoid it because otherwise
Exactly.
we will not get the exact solution. Always we
Exactly.
will get the approximate solution.
Yeah.
So for at least the problem which is linear, always we will go for the our simplex method or whatever it may be, the closed form solution,
Yeah.
so that we get the exact thing.
Exactly.
Usually we go for heuristic whenever I have the nonlinear optimization, nonlinear problems where it becomes very difficult to get the exact solution.
Exactly.
Then only we go for heuristic approach.
Yeah. That's why it has been said that heuristic approach is the last resort to
Yes,
handle the situation.
yes,
Yeah. But there also the requirement is that, as I said, that we need to check for every iteration whether the solution is feasible or not. That's why for checking the feasibility condition, we need to embed the feasibility requirements as a resource constraints.
right.
That's why I said from the previous fact, if we can formulate the rules, then rules can directly be applied because it will find its feasibility from the rule itself. That's why I said in this we do in reality. Again, I'm saying this is beyond the scope of this course. Since you asked, we are trying to answer you.
Yes.
Any other query, please? Now, the next question we would like to know from the participants that whatever assignments we are providing, is it useful?
Or not, yes.
Yeah, because if you want more input or anything, you have the forum you can contact, but this is another forum to directly reach us. That's why we are asking you if you have any difficulty, if we know your level of difficulty, your level of um, the method not to understand anything, then we can give you more input on it because as
At
a
least in
whole,
the forum also.
yeah, at least in the forum also. That's why we want that at the end of this course at least you should say that we know the basics of optimization models,
Whether it is linear or non-linear.
non-linear, anything. Yeah,
Yes.
that is our expectation. You should feel it that he in this situation we can apply linear programming, in this situation we can apply non-linear programming. Mere doing the other than the calculation, mathematical calculations, we expect that you should understand the difference between the models we will teach you in every
Yes.
classes. There is no other query, but what to say more I do not know. Let us wait.
Let's wait for some more time.
Yeah, Mr. Dash, what to do?
Madam, please wait, sir.
Yeah.
Yes, yes. Chayanika, you got any material?
No, sir, I don't have anything in my laptop. It's maybe in the lab computer only.
Okay. So they have not given no more questions are there, Professor Chakraborty?
Yeah, no, not really. There is.
Madam, sir, please wait 5 minutes. After 5 10 minutes, you have no question, then we can discuss.
No, that's okay. It's already, I think, around 45 minutes is over.
Okay, sir.
So let's just wait for another 5-10 minutes.
Sir, there is another query.
Mhm.
Briefly discuss transportation problems.
Transportation, I think,
Not yet been covered, no?
Yes,
has
yes.
not been covered at
The
all.
videos are not online yet.
Yes,
Transportation problems.
Then he has to wait for some time to get it.
just wait for some time. So once the videos are on, automatically you will get it, and during that time, if you have any query, you can ask. That would be better, I think.
Yeah.
Because otherwise we can say something, but which may not be useful for the students. Only only thing I can say in brief details that optimal transportation and the study of the optimal transportation and allocation of resource
Yeah, the
basically
basics
is
of that.
coming, yes, transportation theory, we call this one. This is a special type of linear programming problem which is addressed by this, and which is in the area of physical distribution of goods and services from several supply centers to demand centers. In other words, you can say that transportation problems deal with movement of commodities from different source to different destination. Basically, it is from source to destination with the overall objective of obviously minimizing the transportation cost. So since it is a special type of problem, so its solution proceed, we can solve it by LPP also, but some other methods has been also provided to solve this type of problems, where minimize the transportation cost subject to the movement of commodities from different source to different destination. So basically, while solving this operation research problem, key part in formulating the model is by decoding the problem. For transportation problem, the problem usually is given in the tabular form or the matrix form, you can say, which we call as transportation table or cost effective matrix. You can just think of a source. There will be a source which can be taken as demand, and there will be other side. Some rows will be saying as source, which we say as demand, whereas columns will be known as destination, or we can call it supply. So demand and supply can match. So there will be a set of source, there will be some values, cost associated with them, and we have to find out the solution. So which source, how much you are allocating, by that way you can find this. So in nutshell, I can say these things, but when you will go through the actual problem transportation videos, then you will find out how to make the solution of transportation problem without using LPP or simplex method also.
Yeah, that's fine, I feel. Now, another question he asked, that is, I have not joined the course in this subject. Somebody asked it.
Okay.
With a very surprising name, Adventure Wanderer. But was watching sir lectures in YouTube. So do I need to register to join the forum? Yes, I feel so.
No, but if he has not registered for the course,
he cannot join the
he
forum.
cannot join, I think.
Yeah.
He has to register, but registration date is over now.
Yeah.
So most probably he cannot join forum, since he or she has not registered for the course.
Now
so
that
I think, is it correct that unless they are registering, they will not be able to join the forum?
Mr.
Yes,
Das,
yes, sir. Yes, sir.
Vibhanshu.
Yes, sir. This is right.
Now there is another query from Kalpesh regarding that reservoir problem. I feel max Z equal to irrigation demand plus industrial demand plus domestic demand. Inflow is input of the equation. Continue previous question. Okay, that's fine. That is your understanding. But to make it complete, I feel you have to say more about it. Otherwise, we cannot give our feedback on this. You have to say that what are the other input variables, rather the decision variables, etc. Because no other thing you have mentioned
demand,
here.
I think what he wants to say, he has to take the three variables.
No, three parts: irrigation demand plus industrial demand plus domestic demand.
No, that he wants to maximize.
He wants to maximize, and where inflow is the input variable. Irrigation demand is the function of inflow. Probably he meant that.
Maybe.
And no other query with it. Now, another query: is it mandatory to attend all the assignments? Certainly, this is good for you. Why not?
No, then only you will learn, you will feel confident also.
Yeah. Now, another question, Dipayan. One of my friends staying in abroad, he also registered for this course. Is there any chance to online exam for him? Bibhangshu, what is the rule for that? I do not know. Professor Goswami can also give some input on it. Person saying in abroad, how he has registered, I do not know.
Sir, I think right now not possible from the app.
It is not possible because, no, but due to this COVID-19,
yes, sir. Yes, sir.
it will be possible because now they are not going to the center, I think. Is it true or not?
Yes, sir.
Now they are giving directly from their home or from their places?
No, sir. Right now, they are not. They have not any proctorate exam, online exam.
Right.
So maybe in future, the NPTEL conduct this kind of
Yes.
exam.
Actually, proctored exam, I will say that the NPTEL coordinators are seriously thinking about it, and very shortly this also will be introduced so that they can take the class from here also. Means they can give the exam anywhere from world effectively. Any other question?
No, not yet.
No, but that whatever he has asked, that is a valid point, and that we have to make it.
Yeah, yeah.
But for that we need the proctored exam, and that is not
If
ready
they're,
till
if,
now.
yeah, if they are interested, we should help them.
Sure, sure. Because otherwise, what will happen? These courses only uh, people
Will
will register
confined
and
in
give it
India.
in India only.
Yeah. But our MOOC program generally it is worldwide. Coverage
It's
is there for every MOOC
yes,
session.
it is there, but they will do it. I think with
Yeah,
seriousness
that
it will be done.
this technical part will be taken care officially. Yeah.
Yes.
Sir and ma'am, there is a problem from the students. There is a clash of date for 3 exams on SWAYAM portal on 20 December.
No, I have seen it. That was the first query, I think,
Sir,
and
address it.
that I will address. I will address with the NPTEL office. I will tell them to look into the matter so that, if possible, it can be resolved.
Okay.
I hope it will be resolved. I will talk with them.
No, now another question or something he has written that thanks for all the lectures on YouTube. If any new lectures are there, it may be updated. Regards. It will be given all the lectures
Yes.
one by one. Just wait.
And if we are updating, obviously those lectures also will be modified accordingly at YouTube.
Yeah,
Don't worry about that.
exactly. Now, any other query, please ask us. We are here to listen you. And what kind of new lectures you are talking about? New topics? Yeah. Can you please discriminate all the methods and why we are moving to one another briefly?
One another means.
Yeah. Maybe he's talking about why we are doing, when we are doing simplex, when we are doing dual simplex, when we are doing bigam method. Maybe he's asking for that. Orko Prof Goswami, he is asking the question. Can you please discriminate all the methods? That means the difference between all the methods, the basic need of using bigam, etc. I hope all has been said.
It has been
In
said,
the
depending upon the problem, various methods has been discussed by which you can solve a problem. Now, if I know various methods, then depending upon what kind of problem I want to solve, I can choose which will be the most suitable one. Then only I will use that particular method, whether it is simplex, BGM, or dual simplex, like that way. But if I don't know all the methods, if I know only one method, then always I will go for it. But each and every one has some advantage, some disadvantage, depending upon the formulation of the problem. So effectively, how you are formulating the problem, and then you choose which kind of procedure, which kind of method you will use to solve the problem, so that you can obtain the result in minimum time and accurately.
Exactly. Exactly. Hopefully, Orko Prabhu, it is clear to you.
And if you go through the videos, at the beginning we have told for each method why this is helpful also. And if you have some doubt, then you may write down at forum. We will give you the more elaborate answer to this. I think that would be much better.
I have another suggestion to the students to understand better. We are giving input to help you to understand, that is fine, but we have given you references of the books as well.
Yes.
Why don't you read the corresponding chapters? Just to read it. Then you will get the link between our lecture and the book representation, and you will understand better.
Right.
Always try to take help of the book. Just make a habit to read the book along with the lectures. Bibhangshu, any other question?
No, madam.
Till now, no.
Now you said you have another online lecture, that's why you just another online lecture they have, they said.
Oh, achha, another from 12.
Yeah. Bibhangshu wrote it.
Yeah, it's almost 12.
Yeah.
So no questions, sir. So you can leave the sessions, but close the
Okay,
session.
Bhivangshu. Thank you then. Thank you, Professor Chakraborty.
Thank
Just
you.
wait 30 seconds.
Okay, sure.
Just
sure,
wait
sure.
30 seconds. I can stop.
Why 30 seconds? We can wait more also.
Yeah. Thank you very much to all of you, the teaching assistants and Professor Goswami and Mr. Dash as well, and very well wishes for the students who have registered in this course, and have a nice time, stay safe. And this is a nice forum to interact you. We enjoyed. Thank you very much.